All right, so this video will focus on classifying the triangles, and this is 7.3 extension. So I'm going to give you a moment. I want you to look at this. I have 6 different triangles, and for this one here, for instance, I want you to think about what do you notice about it. And I notice that 2 of the angles are the same, so that means something. And then the sides are the same as well. So I definitely have isosceles. I also notice that all the angle measurements are under 90 degrees. So this is an acute isosceles. This one here is going to be right angle. So this is going to be a right isosceles because the 2 sides are also equal. This one here appears that it's going to be obtuse because of the 104, and all the measurements are different, so it's got to be an obtuse scaling. This one here again is obtuse, but if you look here, these are actually isosceles as well, aren't they? So it's an obtuse isosceles. This one here has a right angle. None of the sides appear to be the same, but so I have a right scalene. And then finally, all the sides and all the angles are equal. So this is an equilateral equiangular. And it's also acute because they're all less than 90 degrees. Basically, what we're looking at for this major unit is just the sum of the angle measures of a triangle. So we did this in previous lessons, but if I add all of them up, it should add up to 180 degrees. And the way that they say that is x plus y plus z equals 180. So if I look here, I have 28, 50, and something. So I first have to solve for this, and then figure out what kind of triangle this actually is. Well, I know that this is going to be absolutely scalene because they're all going to have different angle measurements, right? That's the first thing I know. If I actually add these up, 50 plus 28 is 78, and that would be 102. So it's going to be an obtuse. So an obtuse scaling, and this should be 72, I think I said, or 102. So 102. And then again, it's obtuse scaling. This one here is going to be 45. This is going to be 90. So this has to also, so 45 plus 90 is 135. And then 135 plus what is 180? 45 again. So if I look here, I have a right, and then this is going to be the same angle measurement here. So that's isosceles. So a right isosceles. Now it says find the value of x and then classify the triangle. So if I look here, I know that this angle measurement is the same, so this has got to be isosceles because they're the same measurements here. I know it's obtuse because I have 128 degrees. I basically now have to figure out 180 minus 128, so that would be 52. And I have to take 52 and divide it by 2, right? And when I do that, I get 26. So again, this is going to be an obtuse isosceles. This one here, I have 60. This is something, and this is something here. I know that it's got to be a total of 180 degrees. So I'm going to have 2x plus 60 equals 180. Subtract everything, and I'm going to have 2x equals 120, and then x equals 60. So each x is the same. So that means that it's equilateral. And then they're all the same, so it'll be equiangular, and it will also be acute. And then finally, here's the very last one. So just solve for x and solve for this x. Now notice that this one has a decimal. Same kind of thing as we've been doing. So just add them up, subtract from 180, and you'll have the x value. In this case, it's 75 degrees. I have the isosceles because 2 sides are the same. I have they're all going to be under 90 degrees, so it makes it acute. This one here, I have an obtuse because I have one measurement that's over 90 degrees. And then when I get this measurement, I'll find out that it's different than the other, so that's a scalene, so obtuse scaling. And that is really